Hey guys, I've been looking for a small robot that fits on the desktop, robust enough to teach STEM classes with. Uh, Most of them are too expensive, and the ones that are inexpensive are not robust enough. So, in this trek into DIY tech, we're going to build our own. So let's go to the bench. So when I start a project, I always ask myself, do I already have a tool that would fit the bill, right? So we we've used the Zumo robot chassis before, and it's a very capable robot, and it's about the size that I'm looking for. But they can be a little bit expensive, right? So it's just for the chassis, it's like $90 to $100 for just the chassis, and then when you start adding the Arduino board and the rest of the components, it can get up there. So I'm looking for something I can hand to each one of the students. So we're going to look for something, we're going to put together something a little bit less expensive than this. So although I would love to use these guys, I think that's for a little bit too much, a little bit overkill. The other thing is, so now we're gonna take a look at what we're gonna use for power. These use AA batteries, and so it works really well. These last a pretty good long time with these AA batteries, and this guy is a pretty chunky guy. He's kind of heavy. So we'll keep the AA batteries. So it works. We know it works. So we'll keep that power supply in there. We're not going to do a power budget and all that, and do the math to do it. We know that works, so we're going to use that. So, but I'm going to change the configuration a little bit, make it more compact. We'll do a 2, 2, 2, and then, we're going to need, what are we going to need for that? We're going to need, you got power. You're going to need a switch, right? Some way to turn the robot on and off. So we got that. How's it going to move around? Tracks are a bit much for what we're doing, so we're going to use wheels. These are a pretty good size, 40 millimeters. They'll do really nicely. This is a continuous rotation servo. So it's a regular servo that's been converted for continuous rotation. So the cool thing about this is we're not going to need an extra drive circuit in there. So we're using the servo drive circuit. They've exposed the potentiometer there so that you can adjust the center, right? Because servos have a center, and it does 180 degrees, 90 this way, 90 this way. This one just continuously rotates in either direction, instead of stopping at the extents of it. So which is really cool, because we'll be able to use the same servo libraries that you drive that just to drive it. You power it, you give it a signal, and it goes. So it keeps that part simple, right? So because this is going to be a skid steer or a differential drive, so we're going to drive the left forward and the right forward, or both in the opposite directions to make the turn. So robot's going to be dragging somewhere. These are ball casters. So the ball goes in there, and that's what contacts the ground. So you're going to have a situation where this wheel is going to be there, ball caster is going to be there. I'll put it on this side so you can see better. So wheel's going to be there, ball caster is going to be there. So obviously you see how that is going to work, and we'll put the kind of in that configuration there with the ball there. It just uses a bearing. You've just got a metal bearing. Some of them have plastic balls that go in there, but you'll see how that goes in there. So we'll use a ball caster in there. And then we're gonna need, so we're gonna use, we'll use Velcro to hold the battery in there, whatever the enclosure is. Then we're gonna need a brain. So I'm gonna use the Arduino Nano. This is a carrier board that we have in our Trek packs for Arduino. These are on our website. If you're interested, you can go pick one of those up in our shop, and that just holds the Arduino Nano. So we put the Arduino Nano in there, and then the pins for the Arduino Nano are exposed, so we can use, you know, the jumpers that we normally use with a breadboard. We're going to stick a breadboard in there as well, right? Because we want this robot to be versatile. So we're going to add components in there. We're probably even going to plug in our motors. We may need a capacitor in there to keep the power stable, but we'll see. We'll see how it works out. Obviously, we're going to have to change this out for pins. So this is a regular JST connector for RC modeling. We'll put some pins on there so we can plug it right in there. Have a power rail in there somewhere. We'll work that out. So now we've got a brain. We've got a way to change robots' behaviors. What are we going to do with this thing? Here, first project, maybe we can use ultrasonic. We'll do the ultrasonic thing and make it a collision obstacle avoidance robot. Yeah, that's a good project to start with. So this would be kind of dull if it's just in a fixed position, right? So we want the robot to be able to look around without having to turn its whole body. We'll put a regular servo in there. So we'll put a regular servo in there combined with this guy, and then he'll be able to turn his head, so to speak. And the cool thing is we'll be able to use the same servo library to run all three of these servos. So the movement servos and the head turning servo can all be driven using that same library. And man, I think that's it, right? Oh wait, we need a body. We need a body for this thing, and we just happen to have a whole bunch of these because I like to source some of the parts at your, you know, like I say, local hobby store, local hardware store, or your grocery store. This is just a food container. Oh man, I think this is gonna work out nice. So this is just a what is it? It's a 1.3 cup food container, or 0.3 liters if you're across the pond. So, oh, cool. So maybe we can put some snap switches there for bumping into stuff, or some other sensors to detect if it's going over the edge of the table, maybe. Nice flat surfaces all around for adding extra sensors. And maybe we can do this, make it look like a snail maybe. We can put the servo, we'll put this servo on top, and then we'll put the eyes up here. Or here, I'll turn it this way so it's easier to see. we'll put the head servo on top. Put this guy here like so. And then the wheels can go into this flat surface here. Oh yeah. And then we'll put the caster right here. Ah, that's nice. And so by doing this, if we have a bunch of, if we've built something up on here with a bunch of jumpers, we have a good way to keep that protected. Yeah, I think that's going to work out nicely. All right, now that we know what we're doing, let's get started. All right, every robot should have a nice stable base, so we're going to start with the bottom there. And I'm thinking we're going to get these in there like that. So what we're going to need to do is, I hate to do this, but we're going to have to cut through here and make a space for the wheel to come up, and maybe we can use that later on to get some sort of encoder or sensor to check the wheel motion. But for now, we just need to get the wheel stuck to the bottom of here. So and cool thing is, you see a lot of lines on here that we can use as a reference. So first we need to find out how big the holes need to be. And so we'll use this guy for that. We'll use our nice caliper. So what I'm going to do is I'm going to just go against the motor here and close this guy down on there. And we'll see how much we need. So that's a good amount. Or a good measurement there. We'll use a card here to make ourselves a nice template. And so we're going to give this a nice even number there to work from. So we'll do that. Make this the left side of that. And wow, that's almost perfect there, but we don't want it that tight. So you can see that just about fits in there. But what we're going to do is we're going to give it a little extra on that side, just to have some clearance, right? And here's our template. So what we can do is we can find a drill bit. So we'll find a drill bit that will give us the ends, so that and this material is pretty easy to cut with an X-Acto blade. You'll see in a second. So we'll make the holes like so. So I'm going to go ahead and take the X-Acto blade and cut that out so that we have a template. I'll go ahead and do that off camera so you guys don't have to suffer through that. Alright, cool. So now we have a nice template that we can use. Let's check the fit. And there it is. So I have my hand up against that motor. Nice. And so this will also help us locate the motor. We're going to use some VHB to stick everything together, so to keep it nice and easy. So this is VHB, or very high bond. It says inside there extreme mounting tape. So this is just some 3M tape. You can find this at your local hardware store. But the red, I'm thinking, indicates there's different levels of mounting tape. This is the most or the highest bond adhesive on this guy, and it's going to be more than it's going to be more than enough to hold this all together. And you can see there are a lot of raised letters and stuff on here, so this is going to take up some of that. Some of those uneven surfaces are going to be taken up by this, and that'll help us adhere better to there. So now we're going to go ahead and take this and lay it over there, and we're going to try to use the lines on there to line this up. I'm going to use the lines to line it up. So there you go. It's right up against the edge there. Let me make sure. I may have to trim this a bit to get it. It's kind of hard to see without while looking through the camera. So what I'm going to do is I'm going to make a line across the side there. So the funny thing about these containers is it has a writable surface, so that you can, write what food is in there. So I'm going to make myself some reference lines here so I can position that template. So I'll put it right up against the line at the top, and right up against the line on the side, and that should allow me to line this up real nice here. And I don't know if you'll be able to see that, but it is working really nice. Okay, very nice. We'll do the same thing on the other side, and hopefully they're there. And it doesn't have to be perfect, because in the software we can adjust how the speed of the motors and everything to get it tracking nice. So when the thing is going to be when we have this thing driving forward, because it's a differential drive, one of the motors is invariably going to pull ahead a little bit more than the other one. We can either use this potentiometer that's in there to adjust those, which easier thing is to do it in the software. But we'll see how to do that when we get to the programming part of that. So that's laid out. I'm gonna go get the drill and a drill bit. We'll drill that out, and then I'll show you how I cut it with the X-Acto blade. All right, now we're gonna drill a few pilot holes. It's always a good idea so your bit doesn't walk. And I probably should put a piece of wood under here so I don't destroy my mat. I'm gonna do that. Hold on. All right, I went out there and found the nastiest piece of wood I could find. But here, I'm gonna drill this pilot holes. I'll turn it up sideways on the next one so you can see what I'm doing. But I'm just gonna go ahead and, this is some tough material, I'll tell you. But it's really good to work with once you cut the holes in it. It's about as straight as those holes are gonna get, I think. This one's kind of separate corner here is kind of messed up. I'll try to straighten that out with these step drills. So for the next part, after you get those in there, you want to get a step drill, and I'll show you what we've got. So these are really good for thin material. So with a regular drill bit, what you're going to find is, as you saw just now, the regular drill bit is going to have a tendency to screw into the material and suck down like that, or it'll pull your material up. So with this, it as its name implies, it steps, or some people call this a Christmas tree bit, but you can get nice holes cut in thin material without it sucking through. So it has a really has a very different cutting method. It's not a spiral, it's more of a chisel spinning around. So here we go. I'll show you how that one works out. And I have the drill set to a slower speed, but let me show you how that one works out. I'll be able to show you the sideways on that one. Be careful with your fingers when you're doing this, and then you'll see that it just dropped down to that next spot. And so that looks about wide enough. Yep. So we're just going to that first, that's 1/4 of an inch. We're going to do the 1/4 of an inch. And we'll do this one. Those are all lined up. This top one I'm going to do off camera because I need to straighten that one off. straighten that one up. It's a little bit off. So we'll meet you back here once I got all the holes drilled here. All right. Almost forgot to show you this, but in order to clean these holes up, just come in from the other side with the same drill bit, and you'll see that the shoulder on the other side will help to clean up that hole. See, it'll just cut away all that excess material there that's left over. And just go in a circular motion like that, and you'll see that's nice. Now you have some nice clean holes. You can get the rest of that with your X-Acto blade, and I'll show you how to finish making these slots now with the X-Acto blade. All right, this part's really easy, but just take your time with it. So we're gonna go from hole you just made to the second hole to make a slot, and so you're just going to follow those lines right to the other hole, make it perpendicular. So this material is pretty tough, but it's fairly easy to cut with an X-Acto blade. So you make sure, and again, take your time doing this, because it can crack on you if you try to rush it, and it would be a shame to lose all this work because you're rushing it. And so we're going to speed this part up for you so you don't have to sit through it. But you can see I'm just making multiple score. Okay, maybe it wasn't that easy, but if you had a jigsaw, of course that would be a lot easier to do, and we can just clean up the holes like this. Or if you have a nice little hobby file, that will also do. This is very sandable, fileable material. So let's check for fit, make sure that we did the right thing there. So bring the cables across the back. Yeah, I believe that will do it. Okay, so we'll also use the holes, right, to line up where we tape these down. And so we're going to bring the cables across the back such that, oh, look at that, very nice. So, which we didn't, I know, we didn't, that's the happy coincidence is that these lines are just at the right spot. We'll still be able to access the screws for the wheels. We'll try to put those in before we tape everything down, VHB everything down. The other thing to look at, now that we've got that in there, is to see where we're going to bring the cables through to the inside. And to do that, before we do that, we're gonna locate the, so we're gonna set up our breadboard right there, which is a very big component for us. And then back here, to give us another little bit of space, we're gonna set up our carrier board for the Arduino, and we're also going to have we're going to leave some space to put the screws for the So while we're doing that, yeah, that would be probably a good place to bring the cables up through. So we're going to have this plate for the ball caster back here. Everything lined up to this line back here. And so we're gonna set this up, and you see the hole patterns leave you enough space to where if we put about a 1/4 inch spacer in there or standoff, we'll be able to get the screws for this guy out to mount our ball caster in there. So everything is working out really nicely. This has a double-sided adhesive on it, so we'll set that there. We'll set this here, and I'm thinking since that's going to go there, I'm thinking we'll just make the hole right behind the center here for the cables to come up, and then we can use that also if we have some sensors externally here. We can bring all the cables through up there. So let's mark that off, and then we'll use the same process to drill those holes. So we're not going to go through the process again for drilling all those holes. We'll just meet you back again here after we lay this all out. And so since we're going to be on standoffs, we can go ahead and bring the cables underneath this guy, and we'll see how we'll get him into here. So maybe we'll come around and put him into there, or we can work that out. So here we go. Next time you see this, it'll have all the holes set up for mounting all of these guys. And maybe what we can do for you, if we turn this into a kit, all of that will come pre-cut for you. We can throw it on the laser maybe. We'll see what this material can we cut this material on the laser, fume wise and all that, see if it's safe. If it is, if we create a kit for this, you can get it at our store. Everything will be pre-cut for you. All you have to do is screw everything together. But here we go. Let's do the rest of that. So all the holes are in there. This is a 5/16 hole. I actually wound up using the center feature to locate this hole. I found that it fit better after I looked at it again. So these are 1/8 holes, 5/16, and just be careful when you're drilling these holes, or all of them, because if you push too hard on there, I found that this material can crack. It's very sturdy material, but it can crack if you put too much pressure on it, and you have especially if you have a corner in there somewhere. And so to clean up the holes, I just use a countersink by hand to do it. That works really well. Or if you don't have a countersink, you can use your X-Acto. Just be careful with your fingers behind there. You can use an X-Acto, and also be careful because the X-Acto can grab onto the hole, and you can wind up widening the hole too much. So I'm gonna stop the video here and put some dimensions on there for you. If that's not clear, I'm also going to try to generate a PDF with these, with all the measurements for these holes, in case you want to recreate this. So next, what I'm going to do is I'm going to rough this up with a little bit of sandpaper and get some isopropyl on there, so that when I do put the breadboard on there, the adhesive has somewhere to grab and it's nice and clean for it. So the progression is going to be, we're going to put the caster in here since the screws go that way. Then we're going to mount the board on some standoffs. So the carrier board is going to go on those standoffs. And then we'll go ahead and put the rest of the components, the breadboard and the wheels and motors in there. And I'm going to save you a little bit of listening to my voice. We're just going to go ahead and go through that. All right, so now what we're gonna do is we're gonna put the ball caster together. I really suggest that you get the instructions and follow the manufacturer's instructions for this one, because it can get like a little. So we've got the base in there already. So we're gonna use the tallest set of bosses to set that up. As you can see, that should give us the height that we need. It's probably going to be a little bit forward like this. So in the final version of this, I'm going to have a 3D printed bracket to hold the motors, so that it's easy. These are easier to install. It's kind of like eyeballed in there with the tape. We'll make a 3D printed bracket, since we're already making a 3D printed bracket for the sensor. We'll do that. But yes, follow the directions for this guy. So this one has multiple. We'll liberate it from the sprue here. So one of them, and the real cool thing about this setup is that it's a really low friction, very low friction ball caster, because it actually has some pin bearings in there, and you'll see here in a second. Yes, it does come with that many parts. There are some pin bearings that go in there. We're going to show you how those drop in. We're going to use a tweezer first. The ball's going to go in there. If we can get it out of here. If we can get it out of the bag. It's been in here for a while. Alright, so we're going to drop the ball in there. It does have a little bit of grease on it. Now we're going to put the pin bearings in there. Let's see if we can grab them. And one on each side like so. There's little depressions in there, and we're going to put those in there like so. Now what goes on there is this part. So you're going to see that this part has two sides, right? So those cups right there are going to go down on there like this. So what we're going to do is we're going to set this on top, and it's got some tabs and everything for it to fit in there, so you can see how all of that goes together. And you can see if I can get it to focus really good. You can see how the pin bearings, the ball is actually up against the pin bearings there. So again, we might have to adjust the height of this whole deal, but there's your ball caster. And then very carefully, we are going to set this without letting it pop all open and going all over the place. We're going to set this on top of there. And yeah, it looks like it's, oh no, it's off. It's way off. Yeah, we may have to make some adjustments there for that, because that's too far. Let's see if the inner one, see if the shorter one works for us. Let's see if we can get it in there without losing everything. Man, they're both so close. We'll try the shorter one first and see how far that sets us back. So now there are some thread cutting screws that come with. So these are the shorter thread cutting screws. We'll use those for that. You see it just drops in there because they start down there so that it guides it on the way down. So I don't know if we'll need the spacers for this, additional spacers for that. We'll put it in like this first and see if that gets us close enough, if it's riding with the front up, we're gonna have to make some adjustments. We'll put some spacers in there to help, because it does come with some longer screws, and I don't know if you noticed on the sprue there are some spacers on the sprue. So we'll see what we do. Let's see. Okay. Well, it's not. I'm not totally unhappy with that. It seems like. Yeah. We'll try out some different heights, and when I settle on something, we'll come back to finish the build. Okay, so there we are. So we used the spacers that came with the Tamiya kit, plus see if we can get that to focus, plus a nylon washer to simulate the thickness of the double-sided tape there, the VHB. So when the new brackets, 3D printed brackets, are out, the VHB is going to be gone. So these will be up against there, and the combination of those should get us exactly where we want to be. So that Tamiya kit's going to work out just fine. I'll show you from the side now. I'll give you the side view. Show you what it looks like from the side as we are set up there, and you'll be able to see that it's sitting right where we need it to be. It's nice and level. I'm pretty happy with that. So we're gonna go ahead and keep the Tamiya kit as is, and we will, like I said, make the motor brackets. And the motor brackets, in combination with the extra spacers from the Tamiya kit that we cut off the sprue, that's going to work out nicely. So now we're going to put the carrier board back, and I'm going to show you a trick that I use to solder your pins onto your Arduino Nano if you don't have them soldered in already. Let's go take a look at that. All right, some of you already know this trick. This is not it's not for you. Don't pay no attention to the mess. It's always gonna be that messy. So no matter how many times you scream at the screen, it's gonna be that way. So this is not for those of you who know this trick. I know some of you do already. We're gonna go ahead and take one of your strips, stick it down in there. We're gonna see where the other one's gonna wind up, and we're gonna put that one in there, and then we'll use the board so that we don't push. You can dislodge some of the pins and they'll push through. So we'll just get them seated in there, and then we'll use the Arduino to push it down the rest of the way. So now you can see there that it's nice and flat there. So what we're going to do is we're going to solder the four corners down first. So when you solder, use your fume extractor. We have it off so that you can hear me talking. So we're going to heat up the joint, and then we're going to bring the solder to the joint and let it go. So you don't want to linger too long on any one solder joint, because obviously we have this set into the breadboard, and breadboard will melt on you. And that's why we use an older breadboard that we may not be using for anything else. So there you go. So after I do that, I'll go from the middle out when I do it. And again, when you solder, you're gonna be able to turn this board around. I'm just doing it this way so that you can see. But there you go. So for right now, we're gonna leave the in-circuit programming pins out for the time being. We're not gonna
use those immediately, so we'll set those aside. So I'm going to finish soldering the rest of these all the way around, and we'll meet you back at the robot.
All right, now we can drop it in there, making sure we have we're matching the pins up with the pins. TX is in this corner, so we're gonna put that down just like so, and there you go. That one's ready to go. Now, of course, if you wanted to save some space as well, you could if you got the bare board, solder the nano right to the board, but then you'd be stuck, right? So if something happens to the nano, you can pull it out. But this way, you can remove the nano and replace it if you need to. We're going to check the fit here, so we're just going to drop the battery on top of there. And we're going to check to see if the top of this still fits down on there like I wanted it to. And oh, look at that. Looks like we still have, well, like a 1/4 inch there. So that's pretty good. That's pretty good. That's going to work. That's going to work just fine. And again, I want to reserve as much space as I can on this side for putting new circuits in there and everything. So we'll do it that way. We'll put the battery pack right above the Arduino, because once we plug all this in, we're not going to be accessing that. See, the power's on this side, so we'll go ahead and do that. So we're going to put the switch in. So if we do this, the switch will be right here. So the switch will be here. So we'll cut the switch in right about here, and then we will, I don't know, we'll see how we bring that out. We may have to extend that power wire. So I think we're going to put the switch there, but we're going to go ahead and extend that so that it comes back this way and follows this one back here, so we can plug we'll plug the power into here, and then we'll plug this back into our VN for this guy. So yeah, I'm gonna go solder that off camera real quick, and I'll be back once that's done. All right, so it's actually started raining. I'm sorry about that. You may hear a little bit of music on the roof here. So I've got the switch installed. So I did have to lengthen the red wire a little bit. I had some of the same gauge on hanging around from other builds, so I used that. A little bit of shrink tubing, as you can see here. Shrink tubing there, and I actually got some shrink tubing on the switch there. So now the way we've got it set up is we're going up to turn on. So what I typically do is I have the common going back to whatever I'm powering. So that way, if the switch is in the other position, nothing is coming out there. So we're coming in from the battery at one of the outer poles. And so that's how I've got it set up. So now we're going to use this the same kit that we're going to use to change the plugs on the servos. We're going to use that same kit here. So this is pretty cool. It comes with an assortment of, so we have pins. We have male pins and female pins available. So we're just going to take 2 off of this strip. Be careful with that. This gets really sharp once you cut that. So we're going to just cut 2 off right there.
Yeah, watch where that one go. That stray piece can go somewhere and catch you. And we're going to use a one of the two position to put that together. And I'll do this one, and we'll use this as an example of how I'm going to do the servos. So I won't. I'll show you what the end result of putting the servos together. I'll give you an example with this. So I've pre-tinned the wires to give it a little bit more strength, because this is a really thin gauge wire. So this is the crimper for these, and you'll see it has an A and a B on there. One is smaller than the other one. We're going to go in the small one, because this is a very fine gauge, and you just hold the pin like so, with this end right at the end of that. We're cinching down, pull the pin back, and let's see if we can get it to focus there. Yeah, there you go. So it's right there, and then we're just going to stick the wire in this end till you see it come out the other end, and part of the insulation is going to crimp on this side. So part of the insulation is going to be crimped on that side, and you'll see some of the wire come out there, and we just squeeze down the rest of the way. And there you go. And then I'll show you how that goes into this housing in a second here. Let me do the other wire off camera. Alright, so there you have it. Both of them are nicely crimped. Now typically I'll go with the ground being on the number 1 or the one that's marked. And all you have to do is you go into the big side of this, and you see that the open side is up. You're going to push it all the way in there. Sometimes you have to get some tweezers to seat it all the way if the insulation is a bit thick. The red one's probably going to go all the way in and seat itself, because the insulation's not too big. Oh wait, let me crimp it down a little bit more. Alright guys, we're back. I used the B side of the crimper. You see it's a little tighter there. Let's see if it goes in easier. It should. Oh my goodness, that was like butter. Okay. And let's try the ground again. This one's going to be harder because it's got that insulation on it. But there it goes. Alright. Pretty good. You have to be careful if you're going to do this, because there you go. You hear the click. So there you go. Now we've got that connector. So now we can do this with it. And let's see. Do we want to put the ground on the outside? We'll put the ground on the outside. So the idea is that this is going to be in here like this, or we can set it back 1 so that when we make the short cable that's going from here to here, we can bring it back under there or around here, however we want to do it. But there's the power. What I'm going to do is I'm going to go ahead and take a marker and mark these so that I know what's what on there. So I'm going to take a black and a red marker, and now I'm going to mark these because I'm always going to plug the power into here. So this one's going to be red, and kind of like you see on your bigger breadboards, they always have a bus. So we'll do that, and then we know that that's power from the battery, positive, negative, There we go. All right, now we're gonna go to, so next time you see this, these cables will be done and power will be plugged in here, and then we'll have the signal wire coming up to the Arduino. Same process for those. I'll show you those in detail, and the links and everything. I'm going to try to put a PDF on the website for you to have that set up. But let's go ahead and go onto the top and start drilling holes there and install everything that goes up there.
All right. So as you can see, we've already set up the ultrasonic sensor holder on the servo that's gonna move it left and right. I've kind of centered it so that it's not, as you know, if you've worked with servos before, the servo horns never sit on there perfect, so it's a few degrees off between right and left, but you can adjust that in the code. What we're gonna do now is we're gonna make the outline here. So we're gonna just grab grab a marker, and again, if you pick up the kit, this will all be like laser cut and stuff, so you won't have to make any of these cuts. I mean, that looks like it's lined up pretty good, so I'm just gonna make a line down the side there, line down the other side, across the back. We're going to try to use the original servo screws to screw this in there. Let me refine these lines a little bit so that when I'm cutting here. So we'll use the original servo screws and this front lip to be where we stop cutting. And so we'll use the same process that we used for putting in the holes for the wheels. And then, so we're going to use the drill. We're going to do the 4 corners with a drill. And then once we do that, we'll score this. We'll score this until this piece pops out. And then we'll come in and shave this down so that this is so that this edge is flush there where that is. So we'll go ahead and do that. And we're going to use a 1/8 drill bit for this, just to make the corners, give the corners a little radius. I'll turn it up this way so you can see that. Hard to line up when you're looking at it sideways. We're just gonna do that on the corners. It's a little bit off. We'll straighten it out as we cut. And so yeah, we're gonna see you back when this is further along. All right, so I'm gonna show you this. So as you can see here, there's a big old crack in there. What I was telling you guys about with not going slow, you know, doing multiple passes as you cut. This is what happened. So obviously with the laser cut one, you're not gonna have those issues because one, the hole's gonna be made for you, and two, with the laser, right, you don't have these forces acting on it while you're cutting. And so let's make the final cut here. See if we can liberate that piece. Yeah, it's disappointing, right? Because this was like really the last hole that we had to cut, and it just didn't work out there. Yeah, put a little too much pressure on it. Like I said, you know, just keep doing the multiple cuts until it goes through. I'll try to push through it. Let's check fit now, see if this guy will fit in there.
Should go right in there. And we're gonna have to, oh no, there it goes. So really cool. There he goes. Hopefully that screw, if we put the screw in there, it'll keep this whole thing stable as he's moving around. It'll keep that whole thing stable so we get some good readings off of the ultrasonic. But here we go. Now we're going to shave off this part here, this little lip, to make the servo go flat against there. So we're just going to rock back and forth like that. Rock that back and forth till we get down to the surface of that, and then just brace this and always cut again away from you. Sorry, always cut away from you. And so we'll do that until we get this down flat right here. And so we'll see you back in a few seconds here. Alright, so I went ahead and took a small drill bit with a jeweler's vise. So it's basically using the took the blade out of an X-Acto and put this drill bit in there, kind of using it like a jeweler's vise, and went ahead and pre-drilled or put some pilot holes in there. As you can see, we don't want to crack that plastic any more than it is, so now we'll screw that down in place with the screws that go to the servo horn. So get those in there, and these are like wood screws. They've got a point on them, so they'll go in there because these are RC. These servos are made for RC use, and usually you're screwing into plastic, so we're good there. And yeah, we're just gonna screw that down like so. We'll put both screws in there to make it nice and secure. And I've removed the head, as you can see, so that you can see. Okay, sorry. So I've removed the head so you can see what's going on here. And we're just going to screw into there. They're going to stick out a little bit on the back side of this, but it's okay because they're fairly close, right, to the servo on the inside, and nothing's going to be near the top of there. There's another change that you haven't seen at this point. We went from using, so we're not going to use the AA4 pack for this. We're going to move to off screen. I made this one up, so we're going to split the two sets of AA's in two, and we'll put one on each side. So why is that? I found that when this whole thing was together, there was not enough clearance between the top of the Arduino and the battery pack. It was close, like you could make it fit, but I didn't like the fact that the battery pack was resting on there. We have aside from the wires coming up, we also have this reset button there, and obviously the USB connectors up there. So we want to get as much clearance, and that also, side effect of that is that it puts the batteries right over the wheels. So we have the weight of the batteries sitting over the wheels. I think it makes for a more stable movement of the robot, but we'll see. We'll see when we get this all together. So I'm going to go ahead and put the head back on there. And then next thing we're going to look at is how we're going to secure the battery pack in there and put the switch in there. And then that'll be it. It'll be time to, it'll be time to do some programming. We'll save that for another video, but we'll we'll at least show you everything wired together and powered up, so you can get to see what that looks like. So yeah, I don't know what we're gonna do with that crack. There aren't any or many adhesives that will stick to this, because it's non-stick by nature. We'll see what we do. It might be just fine. It looks like it's, once that servo was screwed in there, it looks pretty good. So yeah, let's get the batteries in there and see what it looks like.
And we're going to use this. So this is this is Gorilla Tape. This is the double-sided. This stuff is pretty strong. So I'm thinking maybe they make an adhesive that'll fix that crack. But we're going to use this to get the battery secured on there. So I'm just going to measure real quick. And so what I typically do, if I need a bunch of these that are the same size, I'll cut one. And then I'll stick the next one that I need to cut right to the back of it, so I could get the measurement. Just make sure you don't stick it to the wrong side, or else they will stick to each other, and obviously you won't be able to get them unstuck. So I just do that. We're gonna go ahead and we're gonna do this. We'll drill the hole afterwards, so we'll locate these two in there. There's a bit of curvature in here and everything, so we're going to take that up by using this really thick Gorilla Tape. Let's make sure that we indeed did that the right way, and we'll separate these. Yeah, okay. We're safe. All right, so I've cleaned everything up. You know, the same process. A little bit of isopropyl alcohol will do it. We're just going to stick this right in the middle there on each one. And you can also, you know, just like we did for the wheels, you just use a little sandpaper, and should be good. All right, so here we go. Let's take the backing off of there finally. And then the backing, it's always hard to get the backing off of these. By nature, the adhesive on this double-sided tape is pretty strong, so you don't want these things coming loose. So usually you can get the corner started. If you can get the corner started, you're good. And it's very compliant, as you can see. It's almost like a putty kind of deal, which is what we want for this particular application. That corner does not want to go, or does not want to stay on the battery pack. But we'll try the other corner. Try this other corner, see if this other corner will be easier to get started. Haha. All right, here we go. I think we got it. We've got it. Let's see. Here it goes. If we can get it started. If you pull directly across, sometimes that works pretty good. Here we go. All right. So now we're going to use the features of the plastic. Make sure we get this in the correct orientation here. We want to switch opposite. We want to switch opposite the servo. So we're going to go ahead and go in here, and we'll try to use the features of that to locate that. I don't know if this is going to work. We might need 2 layers of tape. If we do, we'll fix that later off camera. It looks like the top of it is going to need a second layer of tape just to take up the slack there. Yeah, we're going to have to put another piece of tape in here, but we won't make you guys suffer through that. But you can see where that is going to land. And so now we'll do a test fit on here to make sure we do indeed clear the Arduino. Oh man, that is, oh yeah, that couldn't get any better than that. And it looks like even with the batteries in there, you can see, you can look in there and you can see it's going to clear that Arduino. All right,
So you're not gonna have to sit through me drilling, through watching me drill another hole. So all we're gonna do now is, now that we know where the batteries are gonna sit, we're gonna go ahead and we see that the switch will indeed fit there. We'll drill a hole here. We'll get the batteries situated with another layer of tape on there to hold those in. And next thing you see is the robot will be together, and we'll take an overview of it. All right, it's raining pretty hard out there, so it's you can't hear anything in there. So I'll give you a short demo. There it is, the finished robot. All right, so that turned out pretty cool, huh? I think the only thing we're going to change is, so as you can see, we added a screw there because the double-sided tape going up against this non-stick surface, it didn't work out. It wasn't holding. So, but you know what? That gives us an opportunity to have a somewhere where we can attach some arms, maybe, or some other accessories. We'll see. But there you go. As always, I appreciate the time you spend with me. We'll see you in the next video.